So we're going to move on to something new. It's called the remainder theorem. So TH'(n) is the short form for theorem. We'll do the remainder theorem in this video. The next one will be the factor theorem. And although you read this, it says if a polynomial f at x is divided by x minus a, the remainder is f at a. That doesn't seem like it really is saying much. So we want to make sure that we understand what all that language is at the beginning. If you need to push pause to give the students time to copy this down, then feel free, but I'm going to move on. So it's better to explain what the theorem is by using an example, and then you can go back and see what the theorem is actually saying. So it says use the remainder theorem to get the remainder. So what we're doing here is we're only interested in the remainder. We don't want to actually go through all the long division. We don't even want to go through synthetic division to get the remainder. Although it's pretty quick to do synthetic division, we want a different way to get just the remainder. And I'll ask you in a moment why you think we need just the remainder. So it turns out that if you wanted just the remainder, all you need to do is sub in the root of the divisor. So right here, again, we see x minus 2. The root of that is 2. So we sub in x equals 2. Okay, that root comes from the same root that we do all the time. You know, I don't expect you to write this down, but if we did this, it's the root, so it's x equals 2. So that's why that x equals 2 is what we're subbing in. And we sub it right into the equation. So here's the equation that's being divided, and we're going to sub in the root, which is 2. So wherever we see an x, we're going to replace it with a 2. So instead of x cubed, it's 2 cubed. Instead of x squared, it's 2 squared. Minus 6 times 2, and then minus 1. And solve. So a little bit of math we can do in our head. 2 cubed is 8, times 4 is 32. 2 squared is 4, times negative 2 is negative 8. Negative 6 times 2 is negative 12, and minus 1. So 32 minus 8 minus 12 minus 1 is 11. And the answer, when we sub in the root, turns out is the remainder. So now if we look back at that mathematical definition, it might make a little bit more sense. So if a polynomial, so here's the polynomial in my example, we'll call it f at x, is divided by x minus a, so here it's x minus 2, the remainder is f at a. So again, you see it was x minus a, the root of that is a. So if you plug in a, or in this case 2, into the function, the actual answer is the remainder. So we didn't have to go through any of the division stuff to just get the remainder. So let's do it again with this one. Again, if you need to push pause to allow the people to copy it down, the class in front of me is going to copy it down. This time, the polynomial, which is x cubed plus 6x squared minus x minus 30, is being divided by x plus 5. So could someone in front of me tell me what am I going to sub in this time? Negative 5, that's right. So the root is negative 5. So we're going to sub in to the equation negative 5. So wherever we see x, we're going to replace it with a negative 5. So negative 5 cubed is negative 125. 5 times 5 times 5, and it's a negative times a negative, which is positive, times another negative. Be careful here. Negative 5 squared becomes positive 25 times 6 is 150. Minus 5 is like plus 5, and then minus 30. Add these up. What do we get? 0, that's right. So this is an interesting one. So very quickly, I actually used the remainder theorem, and I found out the remainder is 0. Why is that special? What does it mean? It's factorable, that's right. Okay. Oh, thanks, Bree. So Bree tells me that it is factorable. It must be factorable because when you divide it, you get no remainder. That means it divides perfectly into it. And remember, one of our goals is going to be able to factor these big, long polynomials. And so if we could figure out quickly that you can find something that's factorable using the remainder theorem, then we'll be halfway off. We'll be off to the races. So because there's no remainder, that means that x plus 5 must be a factor.